Teammates?
Alright, my name is Chris. Kim is driving the robot and Ellen's behind me. Kim and Ellen are mechanical engineer students. I'm an EBCS major, however I'm doing a minor in mechanical. So all of us took Slocum Spanish 2007 class together. And that class is a robot competition similar to this but not autonomous. So we have a mechanical bent to our team.
Do you think that gave you an advantage over the rest of the teams?
Well, I think mechanical engineering teaches a lot about designing mechanical systems, and the whole process of being on time when you design something. So it allowed us to be able to feel comfortable with solid modeling and being able to build what we designed. So that was a big help.
So can you explain what all those lights on the top of your robot are doing?
So there's a big red lamp near the center that will light up whenever it sees red. There's a green light towards the back which lights up if it has a ball. And there's UFO lights around the perimeter which will speed up if it gets closer to a ball.
It looks like you are also using Omni wheels?
Yes, the Omni wheels are actually fairly easy to use. We thought they were easier to use than two wheels. It allows us to maneuver around. It allows us to move around while keeping our eyes still on the object, which is great for when balls are near walls or just behind something. It allows us to move sideways to the right.
So how are you lining up with the ball?
So, unfortunately, our robot doesn't shoot very far. It's only about 2 feet if we're lucky. And so we have to get very close to the goal, which is unfortunately, we can't see the whole goal. So if part of the goal is off to the side of the screen, we try and translate to try and get the whole goal in our field of view. And we figure close enough as if we can see 90% of the goal in our view. And so our robot navigates simply by bouncing around. If it hits a wall, it uses our rotating IR sensors to scan around to figure out what kind of position it is. It's doing,
what was that?
It does R2D2 sounds every state change. And you see the red light on the very top says it sees a ball. And if it loses a ball right after it sees it, it goes into a little quick scan. So it can do a back and forth to try and re-find it. In fact, if we look on the screen, we can actually see what the IR radar can't see as well. We're doing a 90-degree front view scan, so one sensor has left 45, and the right IR has the right 45 degrees. And so using that, you're not purely accurate in one situation, but against the wall, you can kind of see what's around it. Every 20 seconds, it does a random 360 scan with both the visual and with the radar thing. It also does a 360. So I was able to see how to get out of this room using that scan.
So how is it wandering?
Just by, it wanders until it bumps into something and then it consults which way to turn. So this way it realized to turn to the left. Now it's doing a random 360, and now it's going to scan 360 the IR, and now it's going to know to go to the left, to find its way out of this place. And so it bumps off the wall, randomly turns to center itself where it sees the furthest range in the IR. So hopefully it'll get us into this side of the field. Hopefully now we'll do that 360 view, and now it's on the ball. Now it sees the way to go out is to the left, and it sees another ball across. Now once it picks up the ball, it does a 360 scan. So now it's still at this ball. Unfortunately, it was too far away, and so it didn't follow it out. If we're lucky though, we'll see the yellow ball to its right. And it did.
So you also have a breadboard on the top of your robot. Can you explain what that's for?
The LEDs and the fan systems all need 12 volt power lines, So only the computer gives us that. So we can either have a bunch of things soldered out of our computer, or we could have one line go to the breadboard.